Harold, good to see you again.
Good to see you again.
Thank you very much for finding a time to see me. I mean, it's been now quite a few years, I think, since last time we had this conversation.
I think we met the year when we released the Alexa 35.
Correct.
In 2020.
Correct. And then,
Yeah,
something like that.
2022.
Yeah. And it was amazing because back then you released C4,
Yes.
which was a huge news. And a lot of things happened since. So thank you very much for hosting me here at ARRI. You know, this is I love this place, so it's absolutely amazing. Thank you for having me. Thank you. And I think, you know, I really wanted to talk to you about certain things. Look, you know, like with any technology that's new, there is always like a little bit, you know, problem with getting to the right information, right? And I think, you know, having the right information is everything. So who better to talk to about all the changes you did with the color science than you? So thank you for that. There is a couple of, I mean, I think it's the three things we want to talk about. We want to start with this update here.
So you want to start with the latest one?
Yeah, I think this is what people are most interested in at the moment. You know, this is just such an interesting development. You know, I know that high frame rate is always interesting to people, but this is really new approach, new thing you did. So tell us about the extreme. So what is new and how does it work? And give us a little bit an intro about it.
Yeah. Okay. Thank you. So that is the upgrade to the Alexa 35, and it can either be purchased as a new camera, or it can also be really an upgrade of an existing Alexa 35. So you, the owner, need to send it in. We will swap hardware in the camera. We need a more powerful processing board for the higher frame rates, and then the client gets it back. The biggest news, or there are two big news here. One is that we offer higher frame rates. So we have in the, let's say, in the normal recording mode, you can go up to 330 frames per second with a 2K crop of the sensor.
Okay, so what was the normal limit that we had in a traditional or like standard?
I think 120 frames.
120. Yes, I think so. Yeah.
Yes.
Okay. So now we go 3 times, right? Pretty much, right?
Yeah. Okay, 330, but as said, in a 2K crop. But also the full formats are a bit faster now. So when you, for example, look at 4K 16:9, we can go up to 125 frames per second, and in Ultra HD we can go up to 190 frames per second.
Okay, so basically you're getting like
140 frames per second Ultra HD, and the other one is a anamorphic crop of Ultra HD, which goes to 190 frames per second.
Okay.
So that's, as said, that's just because we can now process faster with the upgrade. The other big news is we normally read out the sensor twice.
Okay. I'm so glad you're going straight to this point, because this was always like a little mystery to me, right? So before we kind of go exactly the number of frames and everything, let's kind of back a little bit. Okay. So what is really significant about this sensor, as we know, is the 17 stops.
Yes.
Right. Okay. So I don't know, like I always thought maybe this is a secret, but maybe you can let us into a secret a little bit and explain to us. So these 17 stops doesn't happen through a single read?
No, there is a single exposure that is important. So there is not two different exposure times or something like this, but there are two readouts from the same pixel with a high amplification and a low amplification.
Okay, so basically what happens, a light hits a sensor photosite.
Yes.
That's the frame. And then you have a processor that can do...
First, you have a sensor which accumulates the charges proportional to the amount of light which hits the pixel. And then you amplify these charges, or this this voltage or this signal. You amplify that signal with a high gain and a low gain. And the high gain is your normal image, and the low gain gives you some additional headroom which has been clipped in the high gain image, right?
I understand.
So,
and wait, and then you blend those two?
Yes. So you get two 14-bit signals for the high gain and for the low gain, and then they are merged into one 18-bit linear signal.
And that happens before it gets written as a raw file.
That happens all basically in the front end of the camera, and that 18-bit signal is then your raw signal from the camera.
Okay, so all of this capture, amplify, blend, it's basically happens even before we even have written a file into memory and put it into. Interesting.
So
that's why
you achieve that.
So wait, so if I remember correctly, Red used to have like a similar method where they would say, "Oh, you do two exposures," but what they were doing differently is they had two exposures.
That's also done in still photography a lot, exposure bracketing. But obviously it can work quite well, but in scenes where there is a lot of movement, you get an offset between the long exposure and the second shorter exposure. You get an offset in motion, and also you can have different amounts of motion blur. And so if you have something which not much movement, perhaps a landscape with some, like an opening shot, yes, but it can be tricky. Also, still photographers know when they do exposure bracketing, when there is a lot of movement, then it becomes really difficult to blend those two pictures.
I remember in Red, there was always a problem. Like there was always problem with motion blur. One frame had too much, one too little, and when you blend, it was very hard. Yeah. So
but that's not
the trick.
Here. So there is one single exposure, which is whatever you choose as the exposure time, depending on frame rate and shutter.
Love it.
And then the pixel accumulates the charges, and that signal is amplified into with a high gain and a low gain.
Beautiful.
This delivers two signals. Each is 14-bit, and then they are blended into one 18-bit signal.
Okay.
And that 18-bit signal is then processed and saved as, either we convert it to the ARRI RAW in 13-bit and save it as a ARRI RAW file, or we convert it to 12-bit LOXC4.
LOXC4. Okay, now before we go into further, because there is now a third option, this is going to be my second question before we move on to that. Let's kind of just clarify. Now, with the extreme, you have option to turn off.
Yeah, we call it overdrive.
Overdrive.
So we read out the sensor only once instead of twice, and therefore we can do double the frame rate. Yeah. So
is this because you have more processing power effectively, or why is it, or you have a less data, or what gives you the ability to increase the frame rate? Because you don't have to flash twice, right?
Yeah, normally, as I said, there are two readouts from the sensor for the high gain and low gain image, and now we only do the high gain image, the lower one, and we don't have the additional highlight information, but therefore we can read it out with double the speed.
And that increases the whole frame rate we were talking about now double.
Yes.
Let's see what are these numbers.
Yes. So now with the 2K crop, you can go up to 660 frames per second.
Wow.
And let's say with a Ultra HD image, also, 3840 by 2160, you can go up to 240 frames per second. With a limited dynamic range, it's around 11 stops. And now you're laughing?
No. When you say limited, 11 stops. I know. But look, I don't know. This is my understanding. Okay, I know you guys have a different idea about it, but most cinematographers don't really light for 11 stops of dynamic range, right? Isn't it? You control your scene a little bit. You're basically you don't need always the 11 stops of dynamic range in your scene, right?
I think obviously it depends heavily what you're shooting. Do you shooting outside, where control is more difficult, right? Do you shoot things which are glossy or which lights, when you have fire or explosions or so, then obviously you have more dynamic range. If you do, I don't know, food commercials or people, then normally, you probably 11 stops is what you need.
Yeah. I understand. No, amazing, amazing. So basically, like what you're doing now is you're kind of creating almost a new camera, right? New type high-speed camera. Are you even in the film days had this high-speed cameras, right?
Yes, that's one. Obviously, the film cameras always could go up to, I think, 250 frames per second. And we always, obviously, that is not used often, but it was nice to have it. The advantage is also that this single gain image, it matches in terms of color and noise perfectly the dual gain image. It just has this
Less
5 stops highlights or 6 stops highlights missing.
Yeah.
So it shouldn't be too difficult to combine those images if you need to intercut normal speed and high speed. So it makes it easier in the workflow. You get the same spectral response of the sensor, the same color rendition, you get the same sharpness, the same texture, like from your main camera. There is you don't need to match 2 different cameras.
Yeah. I mean, like I have to say, I mean, you're kind of making me a little bit jobless because I used to do a lot of jobs where I would match Phantom to the main camera.
Well, I mean, the Phantom can go up to, I don't know,
1,000.
so that's not our domain.
But you don't use it as high all the time that you. I see. I know, but this is great. I mean, I love it. Very interesting update, and also very interesting timing how you released it. Like, I love it. I love it. Okay, good. So this is the Extreme. Is there anything else that's new about the Extreme?
Yes. There is also, in order to write those high frame rates to the existing drives, we needed to introduce data compression for something which is more like ARRI Raw than ProRes. So we called it ARRI Core. It's a codec which we developed during the last 2 years.
I love the name, by the way, ARRI Core. I love it. Yeah.
And it's an RGB file, but it's less processed than like a ProRes file. And you can still swing around the white balance in the same way you could with a RAW file. And you can also change the ISO in the same way as with a ARRI RAW file.
But this is pretty much all why we were shooting ARRI RAW. I mean, in a way, like we were shooting RAW so that we can have a freedom to decide. No, first of all, look, I think like if we are to compare ARRI Core with ARRI RAW, so it's a kind of the naming, okay. So basically, in terms of the freedom, what you can do post recording is the same, isn't it? Both have a like then ISO and white balance.
Yes.
So that's identical.
Yes.
Okay. In terms of the ability to capture dynamic range of the camera, both are identical.
Yes.
100%.
Yes.
Okay. All right. And then in terms of the size?
Well, there's a white paper where you, for example, that gives you the resulting recording size for 1 hour in 4K 3:2 open gate. So, and you see with ARRI RAW in 13-bit, you would end up with around 2,000 gigabyte per hour.
Per hour.
And with ARRI Core, it's a bit less than half of it. And you see it's similar sized or even a bit smaller than ProRes 444.
Wow.
So it has, let's say, it has about the footprint of ProRes 444. But as I said, it provides the full flexibility of a RAW file.
Now, can I ask you something? In terms of the playback, right? So how do I play back these files?
Well, that's the other advantage, if you want. This file also runs through our SDK. So you need to have a grading or editing system where the ARRI RAW SDK is integrated, which is for many
All, pretty much, yeah. Okay.
And then for workflow, it will be exactly the same. It's an MXF file, like the ARRI RAW file. It's processed through the SDK, and the SDK will hand over a logc4 image to the host application. Nothing changes.
Nothing changes. Okay, but is it like a little bit maybe easier on playback because it has a lot of less, more or less, the compression or
Sure,
something?
you have less data rate to the hard disk. So perhaps if you have a network-based file system or so, that may be an advantage.
Yeah.
On the other side, there is a bit more processing happening because obviously we need to do the decoding of the images.
But that all happens on a GPU already anyway.
That happens in a GPU accelerated way.
Brilliant. Now, look, I have to tell you now, this is now from the kind of front lines a little bit. You know, there is a German colorist, Dirk Meyer. I'm not sure if you know him. Yeah. Dirk did a great presentation on camera image where he kind of made the point: should we shoot ARRI RAW at all? I don't know if you remember that, but I loved it. And I actually always pointed any one of my customers, because we have these conversations a lot. Okay, we're prepping for a film. And of course, everyone always wants to shoot ARRI RAW, but then, you know, the budgetary constraints, time it takes to back up. Okay, we have HDE kind of stuff, you know, okay, that's okay, you know. But you know, there is just, everything gets a little bit, you know. And I always used to point my customers to the talk from Dirk, where he kind of, you know, one of his students, I believe, did like extensive testing and compared the ProRes 444 to ARRI RAW output. And okay, they used pretty much mostly like a relatively normal exposures, right? I'm pretty sure if you go extreme, you might be able to see more. And there was very little. Harold, I mean, the way how you integrated ProRes already was so good. Like there was very, very, very little in there. Now, what do you think now would be an advantage for me, or what do you think? What would be the reason for me to go for ARRI Core if I'm saying like, okay, but ProRes 444 was working for me so well? What do you think it's the main advantage of that?
Well, the main advantage is probably that you are prepared better for those extreme situations where you crank up saturation or contrast or exposure quite a lot, or where you really have to swing around color balance a lot.
Okay.
The other advantage is also that I think that the raw format, should I say it? Perhaps coming to the ARRI Core currently, we are still releasing this as a beta version. So for two reasons. We have a bit of issues with the playback in the camera, only in the camera. And the other one is we still want to do some quality improvements in the file itself, or in the decoder, not so much in the file, but in the decoder. But those quality improvements are really probably only seen in keys, for example. Yeah.
Green screen.
So green screen, blue screen, or whatever color key. So it's not so much that you would see it with your eye if you look at images, but obviously visual effects always has been a domain where people wanted to do ARRI RAW, and we want to achieve the same quality here.
But also like with the ARRI Core, I have the flexibility of being able to change ISO.
Yes.
And I can change white balance.
Yes. I mean, obviously, you can also change white balance a bit in a logc file, right? I mean,
yeah,
Colorist do this all the time.
We do it, yeah.
But if you want to do a big change, then it's easier, let's say, to do this in the ARRI. And the processing in the SDK of the ARRI Core will be the same as for ARRI RAW. So you have the same type of color correction, the same filters, and the same
textures,
and textures, and yeah, all of this.
Excellent. Yeah. Okay.
And whatever we may come up with later, that's, you could say that's, I mean, the big difference between a ProRes and an ARRI RAW file is, as the ProRes file, whatever is baked in, right? We cannot it does not run through our software anymore. So the camera creates a file, and the host application will read it without
never touching ARRI.
An ARRI SDK or ARRI software, because it's a generic codec. That's the advantage. You can play it back everywhere.
Yeah.
Almost.
Yeah.
The disadvantage is that we cannot come up with something new or better, because whatever is in the file is there. It's done. It's recorded, right?
Yes. It's baked in. Right?
It's baked in.
Yeah. And here we still preserve the flexibility. Okay, now most of our audience will be familiar with the whole kind of red patent and them holding the keys to any company compressing raw in camera. But what's very smart, correct me if I'm wrong with this, is that you're not really compressing raw.
No, it's an RGB codec, and it has
fantastic.
It avoids issues with licenses and patent infringements, but also it allows us to do some things which are easier to do in RGB images. For example, we can generate much faster a proxy image in the SDK.
That's very interesting. So, I'm really glad you bring this up. Okay, so help me understand this. So the way how this codec is built, which is, I understand, proprietary, but has a one particular function, which is that the proxy file generation is actually faster.
Yes. So we can, which means, for example, when you are in your editing or color grading software and you move the cursor across the timeline,
correct,
then normally the host application will only ask for a proxy,
correct,
not a full quality image, so that you can have a fluid motion of your cursor in the timeline. And in this case, we can normally, when you have a compressed raw file, you need to decompress the whole raw file. Then you need to generate your RGB, and then you reduce return a reduced size perhaps of the RGB.
So there's a lot of decompression time that
and we can do this faster in this case, because the way the codec is built, we can hand over this proxy image faster.
Okay, so would that mean that, for example, we would be able, when let's say we have a big file that came out of camera, and I need to now create a proxy so that can work with Michael Cioni's new file transfer, we could be able to do very fast transcoding or something like that?
Yeah, I mean, technically, yes. I don't know if any software would support it right now. I mean, normally the
SDK is out. We could
the SDK is out, but yeah, it's true. You would, I mean, normally, as I said, the host applications, they only request these proxies when you do some scrubbing. But yes, technically it would be possible to read and process the file faster if you say, I want to create some HD proxies.
Correct.
Yes.
Which is most of the times, what happens is okay, we just have a file, we are kind of backing up, and I just quickly want to give, DP or somebody upload quickly an HD, preview, right? Can the camera record at the same time proxies in the camera as well, or no?
No, we don't have proxies. We don't have, you mean with proxies like H.264, H.265? No, we don't have that.
Okay, so that's perfect then. So then that means okay, I really need quickly proxies. So ARRI Core could be a great way for me to be able to potentially accelerate that process.
Yes, but it still needs some processing, the RGB. So it's not a ready-made video image or so, because...
But somebody who is smart enough to understand that functionality could definitely accelerate transcoding process by being able to access it. Very
So let's see what comes up with...
How old is this? This has just come out now.
This is now, I mean, this is 2 weeks old.
So we are on the cutting edge here. Okay. It's going. Okay.
And as I said, it's still officially in a beta phase. So we offer here something which I think no other manufacturer, at least of video cameras, does. People can now make tests because they can record in ARRI RAW and they can record in ARRI Core. So everyone now can convince him or herself about the quality of the codec. and can do critical tests, whatever they have in mind.
Yeah.
And we welcome feedback. Yeah? So we
Yeah, I have to say, like, you know, even before when we were choosing ProRes 444 Terrero was very hard. I have to say, and I can only imagine, you know, the difference between our and our core is gonna be like, you know, very, very difficult. Very difficult. I mean, like honestly, a lot of tests we did was for us. It was really hard to understand. Like, okay, where, you know, sometimes it's a really question of preference almost rather than necessarily the image.
Sure. I mean, the images, yeah, you know, there are differences when if you record ARRI RAW and record ARRI Core, the same sequence, or you know, some test shots or whatever, they will not be identical because there is, for example, noise. Yeah? The noise is always slightly different, so you will not have the same image pixel by pixel, bit by bit, but the overall look will be the same. I mean, not only the look, but the overall. Even if you now take the image into grading and start to push it really hard, like, you know, increasing contrast, increasing saturation, you will
behave the same.
They will behave the same, yes.
Brilliant. Brilliant. Okay. This is big. So this is big. That means like, okay, actually kind of it opens the door for like a high resolution capture, you know, where we can just, you know, really easily capture even higher resolutions than 4K effectively because now we have a file format that is at the level of RAW, but losslessly really, you know, is able to, you know, capture this data.
Yes. And
we should have had it before, actually, when I think about it right now, right? Isn't it?
Yeah, but obviously, as said, we now invite people to do tests, to give feedback.
Now I want to talk about the advancements in color management. Because, you know, when we had our conversation, you just came out with the new ARRI C4. And then what I loved, like, you know, I personally loved it the way how you did it, that you had a creative look that was going log to log. Which I still think it's the right way how to do it. So, you know, it's a kind of LMT or whatever we call it. How would you call it in your software?
We call it CMT.
CMT.
Creative Modification Transform.
Excellent. Okay, great.
We thought LMT, that's so tied to the ACES world.
Yeah.
So we called it CMT.
CMT. Okay, great. And I really like actually kind of encourage kind of, you know, this separation between like you know, your output tonal mapping, you know, your device transforms and creative. I really don't think that, you know, it's a smart idea to put it all into one, unless you haven't got the processing power and you have to understand. So it's because, you know, they're kind of two separate things. It's good to have them separate. However, you know, nothing in post-production or production is straight. And, you know, like this is one thing about our job is just there's always, every production is different, right? Everyone, you know, has a different requirements. And the first thing I think it came out, and I think we kind of touched it back then, was like, hey, but I work, let's say, in ACES pipeline. And especially now, since ACES 2.0 looks so beautiful and it has such a beautiful, you know, the RTs, like, okay, you know, this is just, you know, good thing to use, maybe standardize. It was extremely difficult for us to build, or almost, I would say, and with a lot of tricks. Yeah, it was difficult to pull it in. Okay, and you listened. I remember even back then you kind of were aware of that issue, right? So tell me what happened and how did you solve this issue?
Yeah, I think two things. Perhaps we introduced too many changes at once. So we went from LogC3 to LogC4.
Correct.
Obviously, there were a lot of workflows had established around LogC3.
Yeah.
And now people were looking at a new log format, and you know, it caused some people didn't like it, and it caused they needed to change their workflows and so on. And then at the same time, we took also away the DRT. We thought that, or I personally thought that, in a world where most stuff is rendered for SDR and HDR, or for Rec. 709 and P3, for example. I mean, normally most movies, those TV shows are rendered for different output color spaces. So we thought that, as you said, that this is the better way to go. But we, obviously, as I said, some people criticized either those who wanted to do more an ACES look in the camera, but also people who wanted just to stay with their usual workflow of creating a show lot and give it to their client, for example, and let them shoot with that show lot. So we listened and we extended the ARRI look file, which before that could only carry this CMT, this log-to-log lot. And now when you go here to the ARRI reference tool and you go on look, and then you see here there is a button called Creative Modification Transform, CMT, right? And then you can turn on custom color management.
That's the button here.
That's the button here. And now you can, but you don't have to load a log-to-log lot here.
So this is a log C4 to log C4.
That's as before. That's as we had with the original color management system. But now there is also an additional button here called DRT.
DRT.
So when you click here, now you can load two more LUTs. One is a DRT for SDR, and one is a DRT for HDR. And now you have to tell the system for both for which color space they are. So you have to tell it if your HDR LUT is PQ or HLG.
So what does it mean? Like so you say Rec 2100 PQ or Rec?
Yeah.
So this is 1000 nits, yeah.
We assume 1000 nits.
1000 nits
for HLG, yes.
And PQ. Okay,
yes.
Great. And
for PQ, you are free. I mean, PQ is absolute encoded. So if you have a LUT which goes up to 4000 nits,
it doesn't matter. It
doesn't matter.
So for you, this metadata here is not. It doesn't necessarily need to specify the maximum amount of nits.
Yes, for PQ not. For HLG, we assume 1000
nits. I can't go anywhere high. I shouldn't, at least. I hope. Yeah? Okay.
And the same for SDR. Now you have to tell it if your SDR LUT is for Rec. 709 or for Rec. 2020. So you can have a wide gamut look for SDR.
But why would anybody, Harold, use 2020?
You can, for example, encode P3 in 2020, right?
Yeah, but that's what I would do normally.
Yeah.
I would never
but you encode the P3 in 2020.
And limited, so P3 limited to 2020. And then you can put your monitor, tell the monitor to be.
Yes. And Rec. 2020 is a video standard, which P3 isn't. Right? So
that's why you call it penitent.
So when the camera talks to a monitor, and also, when it needs to convert from RGB to YCBCR, there is no defined encoding matrix for P3. There is one for Rec. 2020 and there is one for Rec. 709, but there is none for P3.
Okay.
So,
this is.
I know that most monitors would also support P3 color space, but it just makes it a bit too complicated.
Yeah, but then you really, as you say, you don't know exactly what matrix you're using to convert from one to another, unless you really go deep into menu somewhere and change. Very good.
So I would say if you want to do a wide gamut preview on set, then encode your P3 in Rec. 2020, both for SDR and HDR. And now you can save this as a R4C look file.
So this is somewhere here, yeah?
No, it's here, you see?
Here.
Yes. You can add some additional data.
What is this? SDR custom color metadata.
You can add whatever you want. It could be some information from your color grading tool, which you use to create. It will be transported in the MXF file.
So just a text metadata.
Text or binary.
Interesting. Oh, wow.
Okay, so you can leave it empty. I mean, it's
So then basically that goes into an MXF container as well.
Yes.
And how
And it goes to the ARRI look file, yes.
Interesting. Okay, and this is the same thing here for custom color metadata. This is for HDR.
Yes. So for both LUTs, you can add that.
Or I just keep it,
Yes.
which probably
then you say save.
Let me just put it on my desktop now. Okay. And that's done.
So,
all right.
And that look file now you can load into the camera. And then as before, you can now configure your SDI ports. You have two, right? You can have here, I want to have an SDR image here and an HDR image here.
Okay, so what happens now in the, so basically camera unwraps my look file.
Yes.
It automatically recognizes my custom DRTs.
Yes.
It automatically recognizes my CMT.
Yes.
And then basically says, okay, now I can write, and then in a menu, it will allow me to assign a specific DRT to a specific SDI port.
It will, in the menu, you select your target color space. And if the target color space is an HDR color space, it will use this.
It will use already. I don't have to go to menus and pick it.
And if your target color space is an SDR color space, it will use the other LUT.
Beautiful.
And it will automatically convert. So let's say you using a white gamut LUT for Rec 2020, but then you want to hook up a normal Rec 709 monitor. That's possible. And the camera will convert the LUT file from Rec 2020 to Rec 709.
So you have another step of processing post DRT that you could effectively be able to
yes. Or if you, for example, you load a HDR LUT for PQ, but then on set you realize your monitor is only doing HLG. But I say only, it's just, let's say it's an HLG monitor, then the camera will convert the LUT from PQ to HLG or the other way around.
I understand.
And it will now combine the DRT with your CMT.
Okay.
So it will build two new LUTs on the fly, which is the combination of the CMT with the SDR DRT or with the HDR DRT.
Brilliant. And then this is a 65-point resolution.
You can load 60.5 resolution LUTs, but the camera will process it with 33. The resulting LUT will be 33 mesh points.
In camera.
But the LUTs are embedded in the MXF file.
Can I ask you now this? So now I build this for camera. So, but for me to, let's say, use it now inside DaVinci Resolve for the dailies, I really have to give my dailies Colorist. I have to give them separate LUT files. They can't do anything with ARRI look file.
Well, I mean, the MXF file will contain at least a ready-made Rec 709 LUT, which, is the combination of both. And in theory, you would be able to either extract the combined LUT for dailies, which is, as I said, the combination of a CMT and the Rec 709
which is exactly the same that camera was using while it was being used and recorded on set. Okay, so we have a record of that in the
file. Or you could extract the LMT and apply it in your timeline, and then obviously further downstream, then decide if you want to master for HDR or SDR.
Okay, so basically then I have to give a separate DRT and a separate CMT that you call to the dailies, and then they can build a node tree and they can do it. Perfect, I understand. Now, here is a $1 million question. Netflix loves ACES.
Yes, I mean, many people love ACES. It's okay.
And especially if you're like supporting productions that are not in the US, you are.
But so if you want to use ACES.
Okay, please take us through step by step. Like, okay.
So let's say you want to use ACES
2.0
with an LMT.
Correct.
So you need some application which combines a LogC4 to ACES CG conversion.
Correct.
With your LMT.
Correct.
And then back into LogC4.
Well, why CG or CCT?
CCT.
CCT.
Yes,
Okay.
So you go from LoxC4 to ACES CCT, you apply your LMT, and then you go back to LoxC4.
So what I would probably use is a JP-Log2 because it has a little more dynamic, but that's another story. I don't want to compare. Okay, so we got that. So that's now my CMT.
That's your CMT that you put in here. Right?
Okay. So I just sandwich in between these two conversion points. Okay, great.
And then on the output side, you now combine a transformation from LoxC4
to
ACES
CCT
and the ODT and render transform for the for whatever target color space you want, SDR or HDR.
Yeah, I quite like the newest 2.0 SDR.
Yeah, they look much
better. Yeah.
So, and you can load this here. And then you have
but they have to be loaded to 65 point LUTs. Yeah, so they're basically,
65 or 33.
Yeah. 33.
And then you have an ACES look pipeline in your camera. And later in post-production, obviously, you would not go between LoxC4 and ACES back and forth, like we did now. You would simply, convert with the IDT, your LoxC4.
And that's going to look exactly the same.
And then apply your LMT, and then apply your ACES DRT.
And then that's it. The look is exactly the same.
Yes.
Job done. Very good. Okay, but that solves the problem. This is it. That's
the only thing which I know some people also now would like to do CDL grading in ACES. That's not possible. That will happen in LoxC4. Because if you connect the camera to some on-set grading system and tune the CDL parameter, the CDL is applied to the LoxC4.
That's if I use a CDL in camera.
Yes, obviously. Yeah, but I mean, if you do an external look management, then obviously you don't need.
Yeah, I personally don't like to do much in camera because I might lose connection, and there's so much going on camera already. So don't worry, guys. I'll do the grading outside. You get me. Like there is so much going on in camera.
Okay, but I mean, if you do grading outside, then you probably don't need any of this. You just feed out LoxC4 to some application which converts it to ACES, and then you apply whatever grading.
Can I ask you this question? Do you think I could trick and I put ARRI LoxC4 to CCT as my DRT?
ARRI LoxC4
to ACES. But you know what? I don't like ACES through the pipelines actually. But no, I mean, the only thing if I was to kind of do a CDL grading on on ACES CCT, so I could just output. I could output different log.
You can put whatever. I mean, the application will not ask. No LUT is forbidden. Yeah, I mean, you just need to know what you are doing.
It's my hacker brain trying to kind of hack it away. Sorry.
Obviously, you need to be aware that the camera. But that's important. Now. You tell that camera for which color space it is.
It is.
And if you select another target color space, the camera will attempt some conversion, which you should avoid. So if you want to hack in some LUT here, go ahead. But then set the target color space in the camera to exactly the same color space you
because the only target color space cameras are these two that are available. This is basically what camera color space was. Okay, fair enough. So I would be pretending that one is
you could say, okay, this is Rec 709, even if it isn't, and you tell them the camera this is Rec 709. Yeah.
No, but sometimes it. Okay, great. Look, biggest thing for us at the moment, apart from wonderful thing you're doing with looks, is texture.
Yes.
Isn't it? It's wonderful, like an area. I love this whole thing, and I'm so excited about it. It kind of I feel like we've reached the limit a while ago now to how much we can emulate and do with looks and LUTs and this and that. So really the creativity in terms of the look development today is all in texture almost, I would say, right? Where we can make a difference, right? Because many cinematographers have already kind of discovered those LUTs that they like, or they kind of have, the looks. They're not like kind of so much experimental in terms of what they try to do. So really where we're making a big difference and big impact is, with texture that to my mind is not just grain, right? There's more to it. So where do you stand generally, from your perspective? What do you think should be happening there, and what's going on with ARRI in general?
Okay, I mean, that was also the other new thing we introduced with the Alexa 35. That was the textures, right?
Yeah.
I mean, feedback is mixed, I admit. Obviously, the bigger studios, they didn't like it so much. They thought it makes mixing cameras more difficult. They thought it makes post-production more difficult. And, if I would do a visual effects movie with 800 visual effects shots and shot with 4 different cameras or so, then I would not play around with textures. Obviously, you will do it later in post. But I hear again and again that people who make smaller movies, they like it. They like it that it comes out as it is, right, from the camera. They don't need to post-process it. They like to play around with it. Some people say it's not enough. The range of adjustments should be wider. We were a bit careful here, perhaps a bit too careful, because for several reasons we needed to burn in some of the processing in the camera already.
Okay.
So that may change. We hope that we find a way around those limitations. And then obviously that, textures become a soft edit like a 3D LUT, which you can turn off and on. And then obviously it would also be possible to allow bolder looks, with more change. But since it was burned in, we were a little, we thought, okay,
very limiting.
Be careful here.
Just sorry to interrupt, but I remember when we did a special screening at ARRI in Burbank in LA, and we got basically to record the test footage with every different texture, and then we played it on your wonderful projector. And then we showed it, and then we did a little voting, right? Who likes the texture most? And the strongest texture won. Everyone was like, this one. And it was the strongest one of all. I don't forget what it was called, something old school or whatever. Nostalgic. That's the one. Everyone was like, nostalgic.
That surprised us also. I mean, texture, most people really talked about the nostalgic textures, which add a lot of noise to the image, artificial or noise to not really emulate film grain, but at least to, give the image a bit more of a film style look, if you want. And a lot of people like this, and there are some DOPs, we made custom looks for them. They wanted even more noise. So we said, be careful. And they asked for this. What we also wanted to achieve is a finer adjustment of details and sharpness in the image, and to allow a bit more, have looks which are more oriented for portraiture and others perhaps more for landscapes, but I don't know. As I said, it was a bit of an experiment. We got interesting feedback, and I agree with you. There is so and so much you can do with color looks, but the texture, to control the details in your image, but also to work with noise or grain or so, that is an interesting option.
Yeah.
It's obviously also difficult to do in our world when you have so many distribution channels now.
No,
right?
but we asked, for example, then I was convinced, okay, this is what we will be doing. We'll be selecting texture, and texture will be chosen in camera, and that was me coming from my workflow perspective. And then it was a audience. I don't know how many people there. And then I asked them, so what do you guys think about putting in camera? And then suddenly, these hands popped up, and there were people who work mainly in visual effects, right? And they were like, please don't do it.
Yeah.
I was like, wait, why? I was explaining, why is it? What's the problem with texture? I said, well, we need to add sometimes a CGI element to a backplate. And if there is a texture and I can't regenerate the texture and CGI element, it just generates incredible amount of work. Please leave the texture for post. Please, guys, don't use the texture. It was like that. And that made me realize that especially on bigger projects that go for cameras like this, we're going to have ultimately X amount of visual effects set extensions. Yeah. And the visual effects supervisor is going to, be against it.
But as I said, some DOPs, perhaps more from Europe, which were doing smaller productions, not hundreds of visual effect shots, they like it. They loved it that it comes out of the camera. They like to set it already in the camera. And so I think in the ideal world, you want to have both. You want to, like a LUT, you select it in the camera, you use it already for your on-set viewing so that you can, because obviously the textures and your color look and the lighting, it all plays together. Right? So you want to have a look on set with your textures, but then you want to be able to turn it off on and then later in post edit if you want or change it if you want, like you would do also with a 3D LUT. Right? And that is obviously the way to go. So far, we haven't managed to develop that system, but that's where it should go, right?
Yeah. I like it. I think this is also where my mind is. I'm very much interested in possibilities of that. Simply because sometimes making the textures is really complicated. Developing textures it involves a lot of processing that's sometimes not real time. So getting it really to work properly will be really interesting. Okay. Anything else that you think we should cover, that people should know, that we have missed or not covered right now?
I think we covered most of it.
Yeah. At least everything that I had on my list was here. No, it was wonderful. Harald, this was excellent update. So thank you for this talk.
Okay.
It was wonderful. Thank you for hosting me.
Thank you for coming here.
I love ARRI, so don't worry. I'll come anytime. So thank you all for watching this as well. Have a great day, everybody.
Okay. Thank you.